So in this video we're going to solve this initial value problem. We've got the second order linear differential equation y double prime minus 6y prime plus 5y equals 3 to the e2t, and our initial values are y at 0 equals 2 and the derivative of this function y is 3 at the point 0. So there's our initial values. Now in previous videos I've done some Laplace transform. So in this video, I want to solve this second order linear differential equation using Laplace transform techniques. So first of all, what we need to do is, if we're going to do that, is to transform this into Laplace transform on both sides. So let's just write that up. So I've got Laplace transform of all of this. I've got y double prime minus 6y prime plus 5y equals the Laplace transform of 3e to the 2t. Okay, so now we've got that all into Laplace transform. What I could do is I can break all these down and do these individually next. But first of all, I'm going to take care of this side here. So a Laplace transform of a function like this, 3e to the 2t. Let's just write this up. So the Laplace transform, and I'll put these in a general form. So I've got k as some constant, e to the at, where a is also a constant. Now the Laplace transform of that is going to give me k over s minus a, where s is our Laplace transform variable. Now for this Laplace transform technique to be valid, our s has to be greater than s0. So that's just one condition we've got here. So the value at S0. Okay, let's just put that in a bracket. Okay, right. So we can transform that straight away into this kind of format. So that'll be fine. So we can take care of that. And then we can break these down individually into individual Laplace transforms. So let's take care of that. So I've got Laplace transform of y double prime. So that's the second derivative of our function y, minus the Laplace transform of 6y prime plus the Laplace transform of 5y. Now, instead of leaving this as Laplace, I can substitute straight in our values here. Now for this one here, k would be 3 and my a would be 2. So k equals 3, a equals 2. Just take a note of that. So let's write that into there. So I've got 3 over s minus 2. Okay, right. Now I need to know what my Laplace transforms are for my second derivative and my first derivative. Now we worked these out in a couple of previous videos. So I've left the link in the description below on how we work those out. They're worth a look. There's some interesting integration going on with those two functions. So, okay, so Laplace of y prime, so we forget this constant, we can take that out. So the Laplace of the first derivative, that will give me s times the Laplace of y minus the value at 0. So that's the value of our first derivative in Laplace transform. Now the second derivative, let's write that one here, y double prime. That one is s squared Laplace of y minus y prime at 0 minus s y at 0. Okay, so we just got that there in that box quite nicely. Okay, so now what I need to do now is all of these Laplace transforms, let's put them into these individually. Okay, so the second derivative, so let's use this one. So substitute that for this one. So now I've got, let's bring it over here to give us a bit more space, s squared Laplace of y minus first derivative at 0, which we've got on here, and then minus s times y at 0, which we know the initial value here, that's not the derivative. So now this one here, what I can do is here, I can take that constant out, so I can multiply everything by 6. So now I've got minus 6 times, so multiply everybody by this, and I've got these ones here. So I've got s times the Laplace of y minus y at 0, and then I've got plus 5 times the Laplace of y. So 5 times the Laplace of y, and that's still equal to our function here. So equals 3 over s minus 2. Okay, now let's just not forget the bracket that goes on that one. Okay, so now let's just substitute some values in from here, and let's see if we can simplify this up a little bit. So now I've got s squared Laplace of y minus the first derivative at 0, which is 3. So that we can just substitute it in, and then I've got minus s times the value at 0 for the function, which is 2, so that's just minus 2s. Okay, now let's take care of this one here. So now I've got minus 6 times s Laplace of y. So I'm just going to write that in there, because we need to go careful here with this minus sign. Y at 0 is 2, so minus 2. And then plus 5 times Laplace of y, and that equals 3 over s minus 2. Okay, now our goal now is to try and get this Laplace on its own. So now what I'm going to do is I'm going to try and expand everything out, including the stuff in this brackets. So let's put everything with the Laplace of y on this side if we can. So here I've got s squared Laplace of y. So let's leave that one there, that's taken care of. I'm going to come back to these in a moment. So here I've got minus 6s Laplace of y. So let's put that over here. So minus 6s Laplace of y. So that takes care of that one. And I'm going to come to the minus 6 times minus 2 in a moment. I've got plus 5 times Laplace of y. So that would take care of that. So that's that one. This I'm going to come to in a moment, but now I need to put these ones in. So I've got minus 3 minus 2s. And here I've got minus 6 times minus 2, which is plus 12. And that's still equal to our expression here on the right hand side. Okay, right. Now let's, these terms here, because I want to get Laplace of y on its own, what I'm going to do is just underline those. I'm going to now factor out the Laplace of y on this side. So now I've got Laplace of y. That can all be multiplied by what's left. So I've got s squared minus 6s plus 5. And hey, look at that, that's really handy. We got ourselves a nice little quadratic, and we can factor it as well, so it's a real bonus inside there. So that's come really good for us. So now what I need to do is just add these ones back in. So I've got minus 2s, I've got minus 3 plus 12. That's going to leave me with positive 9. And then that equals 3 over s minus 2. Okay, right. This is coming along really nicely now. So now what I'm going to do is I'm going to factor out this quadratic here, and I'm going to put this stuff on this side here. So let's take care of that. Okay, so now I've got Laplace of y. Now factoring this out, I need to get positive 5, so minus 5 times minus 1 will give me positive 5, and minus 5 plus minus 1 will give me minus 6. So now I can factor this out as s minus 5 and s minus 1. Just be careful not to get your s's mixed up with your 5s, so really important there. So now I put equals sign, 3 over s minus 2, and then bring these over to this side. So now I've got plus 2s minus 9. Okay, right, that's where we are so far. Now to get s minus 5, s minus 1 on this side, I just divide both sides by that. But first of all, I might need to take care of this s minus 2 here on its own in the denominator. So I'm going to multiply everybody here by s minus 2 divided by s minus 2. So first of all, let's make a bit of space, bring this up to the top, and let's continue from there. So let's just take care of this 2s minus 9 and get a denominator the same as this one here. That's going to need to be done before we can bring these over to do this properly. So let's take care of that. So now we've got this one equals 3 over s minus 2, and then each one of these times s minus 2. So I'm going to just multiply the whole thing by s minus 2. So plus 2s minus 9 times s minus 2, and then divide that by s minus 2. That way then I've got the whole thing, nothing's changed. I've just factored that one into that, and then that one becomes there. So I've got s minus 2 over s minus 2 times that term there. Okay, so now rewrite that with just s minus 2 on the denominator and just one expression. So now I've got 3 plus 2s minus 9, s minus 2, and that's all divided by s minus 2. Okay, so now what I can do here now, divide both sides by this s minus 5, s minus 1. So let's just write this up here. So Laplace of y, s minus 5, s minus 1, divided by s minus 5, s minus 1. So now I'm going to do the same on this side. So now what I'll do is I can just write s minus 5, s minus 1 with these as well. So I'll just put those in here and s minus 5. That way then I haven't changed anything yet. So now these will cancel out, which is really handy. And now I've got Laplace of y all on its own. So Laplace of y equals 3 plus 2s minus 9, s minus 2. So that takes care of that. And then I've got s minus 1, s minus 2, and s minus 5. Okay, right. Now, to do the Laplace transform inverse style on this one, I can't really do much with it. So I need partial fraction decomposition. Now, if you check the link below, we did this in the last video to break this into partial fraction decomposition. And the result came out, and this equaled 5 over 2 times s minus 1 minus 1 over s minus 2 plus 1 over 2 times s minus 5. Okay, so they're all s's. These are not 5s. So notice they are all letters. Okay, right. Now the inverse Laplace of these, we can just go back to this, and instead of going from this to this, we can just go from this to this. Okay, so let's just put our Laplace of y just to be correct. So therefore now our inverse Laplace of this will just give us our y. That would equal, so I've got 5 over 2. And then it's going to be the exponential function raised to the power of t, where my a is just going to be 1. So that's going to be e to the t. So that takes care of that one. This one, here I've got my k is going to be 1 and my a will be 2. So that's going to be minus e to the 2t. So that takes care of that. And then we can add a half times e. Now this is s minus 5, so therefore a is 5 and the k is a half. So e to the 5t. Okay, so that's there my function of t. So now just to simplify this off if we can divide everybody by 2 here, so we can multiply that one by 2. So now my answer, I'm going to write him over here, my y of t, that equals 5e to the t minus 2e to the 2t, so I want to get a 2 underneath, so I'm multiplying by 2 over 2, and then add e to the 5t and divide all that by 2. And that there is the result of my initial value second order linear differential equation. Okay.